Ever wondered how thousands of parts in a car engine or airplane wing fit together perfectly? It's not magic. It's the power of geometric dimensioning and tolerancing, or GD&T. GD&T is the universal language engineers use to define exactly how a part should look and function. Without it, manufacturers would face endless miscommunication and parts that simply don't fit. GD&T isn't just numbers on a drawing, it's a system for communicating design intent. It tells manufacturers which features matter most and how much variation is allowed for a part to work. This is critical in industries like aerospace, where even a tiny error can have huge consequences. Instead of long descriptions, GD&T uses standardized symbols with precise meanings. This symbolic language lets teams worldwide understand each other's drawings, making global manufacturing possible. In this guide, we'll break down one of GD&T's most fundamental elements, the feature control frame. You'll learn what it is, how to read it, and why it's so important. Whether you're a student or a seasoned pro, mastering the feature control frame is key. It unlocks the ability to read engineering drawings with confidence, and it empowers you to communicate your design intent with clarity and precision. Let's get started. What is a feature control frame? It's the rectangular box on engineering drawings that holds all the geometric tolerance info for a feature. Think of it as a compact sentence describing a geometric requirement. The first compartment shows the geometric characteristic symbol, like flatness, position, or perpendicularity. There are 14 standard symbols, each with a unique meaning. The second compartment gives the tolerance value, sometimes with a diameter symbol or a material condition modifier like MMC. The remaining compartments list datum references, exact points, axes, or planes used for measurement. Up to 3 datums can be listed, creating a coordinate system for consistent inspection. The feature control frame packs all this info into one clear instruction. Mastering it is the key to understanding GD&T. Let's see feature control frames in action with a simple example. Flatness. The flatness symbol, a parallelogram, attached to a tabletop drawing, tells the manufacturer the surface must be flat. The tolerance value, say 0.5 millimeters, means the surface must lie between 2 parallel planes 0.5 millimeters apart. No datum is needed. Flatness controls the feature itself. Now, consider perpendicularity, symbolized by an upside-down T. If a bracket face must be 90 degrees to another, the controlled face gets the frame, and the reference face is marked as datum A. The frame might read a perpendicularity symbol, 0.2 millimeter datum A. This means the surface must be within 0.2 millimeter of perfect perpendicularity to datum A. These frames make it easy to specify and inspect critical relationships between features. They remove ambiguity and ensure everyone understands the requirements. Even simple frames can have a big impact on part quality. That's the power of GD&T in action. Let's move to more complex frames. One of the most powerful GD&T controls is position, used for features like holes or slots. The position symbol, a circle with a crosshair, controls where a feature's axis or center plane can be. The frame might read position symbol R0.1 MABC. R0.1 means a cylindrical tolerance zone. 0.1 millimeter in diameter, MMC, allows bonus tolerance as the hole size increases. Datums A, B, and C create a 3-plane reference frame for measurement. This setup ensures the hole is in the right place, with flexibility for manufacturing variation. The diameter symbol is crucial. It defines the shape of the tolerance zone. Without it, the zone would be 2 parallel planes, not a cylinder. Position frames are essential for assemblies where precise fit is critical. Reading them correctly ensures parts work together as designed. That's why mastering complex frames is so important. Interpreting feature control frames accurately prevents costly manufacturing errors. A common mistake is ignoring datum order. Always follow the ABC sequence for inspection. Don't overlook material condition modifiers like M. They add bonus tolerance as features deviate from their maximum material size. Always check for the diameter symbol. If it's missing, the tolerance zone isn't cylindrical. Every symbol in the frame matters. Misreading one can lead to rejected or faulty parts. The best way to avoid mistakes? Think about the function of each feature and why the tolerance is needed. Understanding the purpose behind the frame turns symbols into practical guides for building great products. GD&T is about making sure parts fit and function every time. Master the frames and you master the language of precision engineering. What's your biggest GD&T challenge? Share in the comments.